So in this video, we'll be looking at a simple way we can use carbonyls and organometallics to generate an alcohol while also adding a new R group. So why is this able to occur? Well, it all comes down to the fact that organometallics are going to be strong nucleophiles for carbonyl addition, and that's because of how that C metal bond is polarized. Now, before we get into that, let's just quickly review what our organometallics are in case you've forgotten. So our organometallics, right, those are going to include our Grignard reagent as well as our organolithium reagent. So how do we synthesize these reagents, right? Feel free to pause the video now and see if you can recall on your own how we can generate, for instance, an organolithium. So if we want to generate an organolithium, we're going to have to react some Rx, some alkyl halide, with two lithiums in order to then get this organolithium, where we have this R, Li, and we also form an LiX. Now, take a minute to pause and see if you can remember how to generate a Grignard reagent. Grignard reagent. Well, if we want to make a Grignard, we're going to have to again react some Rx, in this case with MgO. And what this is going to give you is this RMgX. And oftentimes this is, MgBr. So these are going to be our two organometallics. So what is it about these organometallics again that makes them great for carbonyl addition? Like I said, it comes down to that metallic C bond, that C metal bond, and the way that it is polarized. So generically looking at what we have in an organometallic, we're going to have this R bonded to some metal. And so we know that the metal here is going to effectively have a partial positive charge, and the R here is going to be partially negative. So our carbon here sort of behaves in a way like a carbanion, right? The R here is like a carbanion. And so that makes it extremely nucleophilic. Extremely nucleophilic. What does nucleophilic mean? Philic, it loves. Philos, loves. Nucleus, what makes up the nucleus? Protons, so positive charge. So this is going to be seeking a positive charge, right? This carbanion. Again, it's due to this polarization that we get because of this metallic bond here, or this C metal bond here. So now, what exactly makes them good at attacking carbonyls? Well, the strong nucleophilic nature, right? This high electron density on the R group is going to mean that the carbon bonded to that Mg or that Li, it carries a partial negative charge. It wants to donate electrons. And now our carbonyls, the carbon in a carbonyl is going to be very electrophilic. Why? Well, if you can recall, right, a carbonyl is a carbon here bonded to an oxygen. And remember, oxygens are extremely electronegative, which means they're going to be pulling on that electron density. So effectively, the oxygen here is going to have a partial negative, and this carbon is going to have a partial positive, meaning this carbon here is going to be a perfect target for nucleophilic attack. And so we have a great nucleophile from our, organometallic, and here we have a great electrophile, as we have the oxygen here, pulling that electron density away from this carbon. And so here we have this sort of favorable bond formation where we're able to form a new CC bond that's going to be very stable, and for us also going to be very valuable in synthesis. Okay, so now that we got this sort of conceptual understanding of what's happening, why it's occurring out of the way, let's look at the actual mechanism here. So let's start with the mechanism for the addition of the alkyl lithium to the carbonyl. So we can start with some ketone, let's say R1, R2, right? And we have this carbonyl now. So now what happens? We need to react this with an alkyl lithium. So the first step is going to be that reaction with the alkylithium. And the second step here is going to be with water. So it's important that you do this distinct numbering. 1, alkylithium, 2, water. They are occurring in 2 separate steps. And what is going to then happen, where we're going to have a product, again, sort of give us this general scheme, what we're going to end up producing is we'll have this new R group as well as an hydroxyl. So our product here is going to be an alcohol. So we're able to generate an alcohol from our carbonyl here, in this case a ketone. So now, what you're going to want to keep in mind is that there are really 2 distinct steps now as we move on to the arrow pushing component. So the first thing here is an addition, right? We're going to have an addition. The second is a protonation. So the addition here is going to allow us to add that new R group, and the protonation is going to allow us to get the hydroxyl and thus give us this alcohol as a product. Okay, so now let's look at our ketone, that R1, R2, carbonyl, and we can draw that alkyl lithium. So what's going to happen is we're going to have the R group attack this carbon, right? We know this nucleophilic attack here. This is going to then cause the double bond, the electrons that make up this double bond, to be pushed onto the oxygen. Why? Because carbon, when this new R group attacks, is going to then have too many bonds if we actually keep this double bond here. So we're going to have to break the double bond and push the electrons onto our oxygen. So then this is going to give us that first intermediate where we end up with R1, R2. We get a new R group here, as well as an oxygen that is now single bonded to the carbon. Again, let's not forget that charge. Now, this is the addition step. So now the second step, remember, is the protonation step. So that's reacting here with water. So we've successfully added the R group. Now what we need to do is add the hydroxyl. How do we do that? By reacting with water. What's going to happen? We're going to have the oxygen here pull off a hydrogen from our water. So if we have a water molecule here, this oxygen is going to grab a proton, push these electrons onto the oxygen, giving us our product, which is the alcohol. Right? So we have the R, and then we end up with the OH. So this is that alcohol product. Now, take a minute and pause again and try to see if you can try to figure out the arrow pushing mechanism here for reacting the carbonyl with the Grignard reagent. So I'll assume you gave it a shot. It's very similar again to what we just did. We're going to react this ketone. In this case, it's a Grignard, so we have the R and then MgBr. Now, one small thing I just realized I somewhat omitted from the mechanism previously. Once we generate this intermediate, right, where we have this oxygen with a negative charge. Remember, all of this is occurring in solution, so it's important that you keep track of your ions as well. So just make sure that you remember to also draw that lithium ion sort of floating around here nearby. So yeah, that was my mistake. I forgot to mention that in the earlier part of the mechanism. So now, similar idea with Grignards. We're going to have the R group attack the carbon. This pushes these electrons onto our oxygen, sort of forming that intermediate that we were just talking about now, where we have the oxygen. We have the new R group. Here we have MgBr+, right? What we're going to now have to do, react with water. What's that going to do? Well, it's going to protonate. This was the addition. Now we got the protonation. So we end up with hydroxyl, so we have an alcohol. And this is the mechanism. So, hopefully everything here is making sense. This isn't a very complicated mechanism. Just keep in mind the addition and the protonation, and everything else should feel pretty logical in terms of the steps here. So, that brings us to the end of the video. If it was helpful, please show your support by liking and subscribing. Leave in the comments any questions you might have, as well as suggestions for future videos, and I will see you in the next one.